Hi all. So today I will give you the overview of the microservice part. So microservice is one of the important feature of nowadays for any kind of application. So before start of the microservice, so I am giving the overview of the monolithic application. So monolithic application means the application which is having one code base, and whenever you are trying to deploy are small changes also, we have to redeploy the entire code base into server. So there are a lot of disadvantage are there in the monolithic application, because there will be a downtime for deploying the changes for a small changes, whatever the changes. Suppose if it is the application changes, whatever properties changes, you need to deploy the entire code into the server, and for that parts reason you have to give the downtime effect. So if you are using microservices instead of monolithic, so you will not have this kind of problem over there, because microservice is a separate service, so it doesn't have a single code base. So whenever you are trying to deploy any changes, you should deploy the particular service, not the entire application. So you don't need to give the downtime for the entire application rather than the particular service. So this is one kind of important feature of the microservice. So before start of the microservice, so there are a couple of advantage and disadvantage we can discuss on the microservices part. So microservice, as I have discussed, that it's a self-contained independent deployment module. Also, the cost of scaling is comparatively less than the monolithic architecture, because suppose let's say an example, you are trying to create one ticket booking system as a monolithic architecture. So there will be a lot of part you need to write in your application code, and that the scaling will be a high cost over there. But if you are able to write as a microservice application or microservice architecture, then the cost of scaling will be comparatively less than the monolithic architecture. So in the microservice, you can manage all the service individually. So you can enable the service based on your requirements. Also, you can minimize the impact on the existing service based on your requirements. The one of the important point is you can change or upgrade the service rather than upgrading the entire application. So this is one of the important feature of the microservice part. So let's say we have one ticket booking system, and we have created the ticket booking as a microservice part. So booking is one service, payment is one service, confirmation is another service. So if you want to upgrade, or if you want to change a small thing, let's say payment service, so you don't need to wait, or you don't need to upgrade the entire ticket booking application. Rather, you just need to upgrade the payment service. So this is one of the important advantage of the microservice part. So another advantage of the microservice is, so less dependency. So as those particular service, let's say payment service or booking service or confirmation service, so as they are individual or independent service, so the dependency for those service will be less, and we can easy to test. So suppose there is one requirement to upgrade the payment service. So the first thing is, you don't need to give the downtime for the ticket booking entire application, as you just need to upgrade the payment service. So there will be a deployment for the payment service only. And before deploying the changes into the production environment, so you can test from your end the particular service. Either you can test via SOAP UI or Postman, or you can just check the URL itself. So this is one of the important feature of the microservice. So you can test via entire application, or rather you can test individually for each and every application. So as this is the less dependency services, so it has dynamic scaling and faster release cycle also. Yeah, there are a couple of disadvantage are present in the microservice part. So the disadvantage is microservice has all the associate complexity for the distributed system. The second thing is the higher chance of failure during the communication with different service. So this is one type of disadvantage. Suppose you want to in nowadays whenever we are trying to book the ticket, so we are facing this kind of problem, right? So once you give the entire details, booking details and train details, whatever the details you have already entered, you entered the OTP, and whenever you are trying to connect the payment service, for some reason either server was down, or some for other part payment service was down, or for some other reason, so the connection between the booking service to payment service might not be established properly, so your payment would be failed, so you can't able to book the ticket in that scenario. So this is the one kind of disadvantage you can say for the microservice part. So if you use the monolithic architecture, so you don't need to worry about those kind of disadvantage for the monolithic application, as all the services are coming into the one code base, so you can easily call from one service to another service from the code base itself. So, and one more thing, whenever we are trying to create the microservice application, we should keep it in our mind that network latency as well as load balancing. So as I have all discussed just a couple of minutes ago, that payment service is failing, so due to the network latency, either server was down, or it couldn't able to connect to the payment service due to our network latency or due to our bad network. So this kind of problem we might face while calling the microservice from one microservice to another microservice, as they are independent to each other. And the one more thing, that is the complex testing over the distributed environment, because in the microservice they have lot of environment like dev, sit, sqv, so sometimes the testing should be the complex part in this particular scenario. But in the overall I would suggest the microservice is one of the important services which we can achieve more faster application nowadays, because it has less dependency. We can easily scaling microservice part, we can do the dynamic scaling, faster release service. Okay, so let's see an example over there. So here I have created two services basically. One is product. In the product table, if I show you here, yeah, so in the product table I am giving the product detail, and the product detail is get the three column, one is id, one is name, one is price. Same thing I have given the order service. In the order, so whatever the product is present in the product table, I would like to order those kind of product. So in the order table I am just giving the particular field, that is order id, the name of the order, whatever the order I just keep want to keep, the quantity, the total amount I have to pay, and the price. So I just here you can see there is two service. One is product service, one is order service. So there are two microservice I have created. One is product service, one is order service. Now I would like to call product service into the order service. So whenever I want to order, say let's say in the product service I have added three product. One is biscuit, one is viscous, and one is muesli. So whenever I want to add or I want to order any of the three product, it will call this particular microservices product services, and it will fetch the product price based on the quantity. It will show the how many much amount I have to pay for this particular order. You can easily write as a monolithic architecture. So but here I just want to show you the advantage of microservices. Let's see how we can achieve that one. So because is as it's the main services, so first I need to run the product service. So before running the product service, so I'm just showing you. So this is a domain, the entity class. So in the entity class there are three column only: product id, product name, product price. Okay. And this is the repository class, product repository, where we are just giving one method called find all product by name. And this is a service class where we are just giving the logic, business logic, basically by calling the repository. Here you can see like that there is auto adding properties I have done. And the last, that is a controller class. So this is a controller class where we are doing the get mapping part. So and we are just returning the product by name. So, as I have already informed you that microservice is the less dependency and we can easily test each and every service individually. So first I need to run this product service, and also I have given you the data SQL. So you just keep it in your mind. So whenever you are trying to add any, insert any data into the table as table, so you can keep like that. So data.sql you can keep, and you can keep the insert the data over here just for the testing purpose. So let's run this example, run as Java application. And I just want to show you one more thing, that is the application properties. So whenever you are trying to write any microservices, you just need to give two things. First, the spring dot application name. So spring dot application name is basically the service name. So here you can see like the product hyphen detail hyphen service. So now I just my server has been started, and the port is 8000 as a default port. So controller is product detail slash name. So let's take an example and see how it will work. Local host. So first I just need to check the table. So here you can see product detail is coming, and if I run this product detail, you can see three product has been all successfully added over there. So if you see this example, this console part, so you can see like that. Okay, so already added those three product, and table has been created. Previously it was not there. Now I need to test whether this application is working fine or not. How to test that one? Local host, then 8000, then product details, then biscuit. Awesome. You see, biscuit is coming over there. So if you want to search with this product, let's say meow treat, you can see that means this microservices is working successfully. So I can use this microservices into the order service to get the details for each and every product. So I just want to give the product name, it will fetch the price, and it will give to show how much amount I have to pay based on the quantity. Let's see. So there is one more microservice I have already created, that is order service. In the order service, I am just keeping here order ID, name, quantity, the total amount I have to pay, and the price. The same thing I have done over here in the controller class. So here if you see in the controller class what I have done, so this is the order details and name and quantity I have to give now, and that name and quantity I am passing through the path variable. Now here if you see like that, I am calling the rest template and get for entity method. Let's see what get for, just a moment. Yeah, so what get for entity method is basically doing. So get for entity method, so whenever we are calling this particular method get for entity, it will do the get mapping. So if you see here the old microservice, the first microservices, the product microservice is a get mapping. So that's why I am using get for entity. If it is put or post, so we can't able to use that one. So it will fetch the URL for the particular microservices, and it will store the result into this class. So that's why if you see over here, this send the request to specific URI, or that means specific URL, to get the details from there and convert into the response body into the requested Java type. So here if you see like that, here what I have done, I have created one response of entity object as a order, because order is the our main entity object, where I just need to keep all the data: order ID, name, quantity, total amount to be paid, as well as price. Now I am creating one REST template, new REST template. Otherwise, here I am creating the new object. If you want, you can auto-ware that, and or you can create, simply create the bean method in the REST template equal to new REST template, or in the top of the tab, you just give at the rate bean. So automatically object will be created over there, and then you can call this one get for entity. So whenever you are using the get for entity, it represent by doing for a get method, doing the get operation by providing the URI template. So here if you see like that, I am giving here the template part. So localhost 8000, then product details slash name. So this is the template. So that means the order service is separately calling the product service by using get for entity method. And after that, what it will do, it will save all the data into particular class, that order dot class. And the variable mean whatever the path variable we are passing from the URI, that variable we should pass over there, otherwise it will not work. Now what I will give here, I am just creating one response, and I am just adding the response body over there. Now what I have done, I am just returning the entire order details. So if you want to return any other things, you can easily return from the as your requirement. So here if you see, I am returning the ID, the name, the quantity, and I am returning the total amount to be paid along with the price. So let's take and see how it will achieve. Now I just want to give, and also before running or before checking the particular order service, I just want to check what is the port number. So here you can see the same thing, the spring dot application name should be the order hyphen detail, and server port is 8081, as I have already run one port is 8000. So let's see. So whatever the application name you are giving over here, order hyphen detail hyphen service, till this you have to keep while writing the URL. So because the same thing I have used over here also, order hyphen details, then you can give the name, and whatever the path variable you want to use, you can give that use. So localhost 8081 slash. So now I am giving, just a moment. Okay, my bad. So let's first try to run this this microservices. So yes, microservice has been successfully started. That now let me, awesome. See here, Whiskas, the idea of the Whiskas is 2, and the name is Whiskas, quantity 100, price 200. So that's why I have to pay 20,000. And if you see here, Whiskas, that what is the ID is 2, what is the price is 200. So this is one of the very advantage of the microservice. You don't need to dependent on the one service to another service. You can also test both the service individually. So here you can test the services individually, and you can see like that. Here what I have done, I got the my requirement. So here I just want to see how many amount I can pay. So now from this part also, you can also connect one more microservices called payment services. So after payment done, the payment for the particular payment, you will get the successful message over there. So let's see. So instead of Whiskas, if I give biscuit, what will do? I'm just giving biscuit. Awesome. Now see, I'm just changing the name. It will call the particular microservice, that that product detail microservice, and it will fetch the price for this particular product name. So here biscuit price is 70 rupees. So and then based on the quantity, it will calculate the total amount to be paid. So there is all the scenarios I have already showed over there. So dynamic scaling, less dependency, as you can test both the service individually. Faster release, you see the service is too much faster over there. And the second thing is, it allows us develop to that independently manageable service. So suppose, let's say, if you want to add more details into the product class. So let's say that if you want to add more details in the product class, so if I go to the domain, I have already added product name, product id, product name, product price. So let's say I just need to add mm, company name. Okay, so from which company it will sponsor, or anything else if you want to add. So whenever you are trying to change anything else in the particular product service, you don't need to stop, or you don't need to give the downtime for the order service, because as they are dependent, as they are not dependent with each other. So we don't need to give the downtime for the entire application. Rather, we just give downtime for the product service, and we just need to modify as per our requirement. And then we need to start the service, we need to call the order details, it will fetch as expected. Let's see. So I just want to add. So first I stop this one. Private. Yeah, string description. So basically I want to add the product description, or we can see the expiry date. So the same way we just need to add over there. Just need to add the greater setter method. We just need to modify that expiry date. Let's see what is the thing we have given over there. Product expiry date. Now I just want to run this application once again. Okay, Java application. Okay, it's successfully run. Now I just need to check over here once again. Okay, select star from product detail. Okay, so expiry date has been successfully came over here. Now let me run this one. Expiry date we got over here. Now let me run this one. You see, no need to change anything. If you want to see the expiry date for this particular product, then you might need to change the ordered service. But if you see the advantage, if you are writing the monolithic application, then you have to give the downtime for entire application. But as it is the microservice application, so you don't need to give the downtime for the entire application. Rather, you should give the downtime for the particular service, that is product details, and you will get here the expiry date over there. So this is one kind of important example of the microservices. So in the next video, we'll come with another important topic. So today I'm gonna wrapping up over here. So we'll see you in the next video. Bye bye, and subscribe Sword of Steady.